All right, good morning, welcome. Thank you for coming. We've got 45 minutes in this session, which I think is going to be more than enough. So we will be taking as many questions or discussions as you want to have at the end. So please be thinking of polite, productive queries that you might launch upon us at that time now. But we're looking forward to that part, having a little interaction there. In the broadest possible sense, we're here today to talk about change, which I know sounds like the beginning of some sort of political speech, but I promise we're going to keep it strictly technical, yeah. Because change is something that happens so widely and to so many people, there are no shortage of visual metaphors. I like this one. I think there are some strange connections between geology and computing, right? This is change happening over a long period of time in neat little stacks with clear delineations between those periods of change. It's just like well-defined architecture, or like well-thought-out software design, right? But in keeping with our friends from the physical sciences, we also have periods of mystery that occur within our change. I'm sure that no one in this room has not been in the situation of digging through some logs or a database, or maybe looking at a Git history, trying to figure out what it is that changed. Like, what happened? How did we get to where we are? This value cannot possibly be 7. It's not possible in the confines of the system, right? So it's with the general sciences, it's reassuring to know that we have that sort of thing in common, right? So, like my old chemistry teacher used to say, chemistry is, strictly speaking, it's a science of matter, right? But he pretends or prefers to think of it as a science of change. I like to think about computing a little bit that way as well. When you think about data, it's kind of the science of ones and zeros, and getting them in the right order. I don't know. But it's more to it than that. It's the process of change. It's this evolution of ideas that are occurring within a system. And that can be, relatively boring sort of numbers in a row, or it can be increasingly more complex things that we can construct from these fun little primitives. Right? And so just like the many faces of Walter White, I don't, for those of you who don't know, this is not, in fact, my chemistry teacher. I don't know, is anybody who didn't know that? Anyways, a character from Breaking Bad, who evolves quite a lot throughout the sort of scope of the show. Each one of the individual faces is very interesting in its own right? But it's the narrative of how we go from one face to the next is where the guts are, where the real interest is. And we think that's also true within many computing systems, in that we are very interested in change and capturing it. Just to set this slide up a little bit, anybody from the younger generation, that's a quarter. Quarter are little metallic discs that we used to use for money before there was like digital forms of exchange. Collections of these coins together were called change. And you put them in your pockets, and then you'd sit down on a couch to drink like a Miller Lite while you're watching the game, and they would all fall out. And then later on, enterprising kids like me would go looking through the couch cushions, collect up all the money, go try to spend it on Miller Lite, get rejected, and end up buying candy or maybe playing a round of Donkey Kong or whatever, right? But that, it's a pun and a metaphor all in one. So I just don't want anybody to feel left out, right? This change is getting lost in our data-driven systems, right? We're storing state, but we're failing to store, in some cases, how we got from one state to the next, right? And I know it may seem crazy, but we used to also take these little metal discs and we would collect them up in paper tubes. I opened my first ever bank account by doing this, by taking a bunch of pennies and nickels that I had, counted out and put in these little things and getting change. But anyway, it's meant to be a visual representation of capturing value from change, which is what we're really here to talk about. I mean, the essential question we're trying to ask is, how can we monetize the change that's happening in our system by capturing this data in a way that maybe we're not doing so right now? Who am I, one, to ask this question, and who am I, two, to answer the question, or to have such audacity? I'm the CTO of Zolvio, as Dan so politely said. We've been knocking around in the GraphQL space for a long time. We're very interested in event sourcing, good friends with Kurrent. And we think there's an opportunity to bring these two ideas together to capture this, or sort of attack this question of how to capture change. So happy to be on stage with Kurrent, so why don't you take it from there?
All right, thank you. Hey folks, my name's Tony Young. I'm a Principal Solutions Architect here on the Field Technical Services team at Kurrent. That is my title and a whole ton of words that basically mean I get to spend my day nerding out with our technology. I love it. I believe in it. I've spent my entire career in consulting, so helping organizations such as yours get started with whatever product I happen to be flogging at the time. Just kidding. That was a joke. You're allowed to laugh. But in all seriousness, I love driving customers to great solutions with technology. And technology has a way of transforming our lives, as we're seeing now and we've heard today with AI being straight on the cusp of it again, and being at a company like ours that I want to show you how central we feel the event is to the story of AI is really quite exciting and quite powerful. So what are we going to talk about today? Well, before I get into that, put your hand up if you know the definition of an event. Some people? Well, I challenge all of you, actually, before we get going, really to put aside what you think the event is. Put aside that definition that you have in your head about what is an event. And let's talk about, from the very get-go, define what an event is, how we can store data as a set of events. We'll look at how GraphQL can capture these events, store them using router customizations. We'll talk about what Kurrent and KurrentDB are and how we can actually store those events and allow you to get great value out of them. So at its heart, data can really be stored in one of two different ways. Most commonly, and the way that I went through the vast majority of my career, is using a state-based system. So something like an Oracle, a SQL Server, a Postgres, a Mongo, whatever it is, to store the state of an object, of an entity. What is the state of my customer record? What is the state of my Amazon order? Now, state-based systems are great if all I care about is the what. But if I want to understand more than that, I need to look a little bit deeper. Now, sure, I can kind of capture history with a relational system, but you got to kludge together a bunch of technologies, and sometimes things break at 3 in the morning, and you get this pager call, and your manager's upset, and your order system is down, and you're losing millions. Nobody likes that, right? Now, if we look at a log-based system, on the other hand, a log-based system looks at the world in terms of capturing all of the state changes that make up your business workflow. Events. Something that happens inside a business workflow generates some kind of application event. That data is stored, and we can then walk backwards and forwards through time. We have full, rich context, full granularity on exactly what happened, why it happened, when it happened, and how it happened. So let's look at this in a couple of real-life metaphors here. I'm not a sports ball guy. I don't know if there's any sports ball people here in the audience, but if you know sports ball, you know that the final outcome of the sports ball game, my kids hate it when I say sports ball, by the way, so it's just baked into my natural language these days, but the final outcome of the game is the score. And we know the state of the game at any point in time if we catch the score of the game at any point in time. But if you're a real fan of sports, you know that what actually makes the game great is all the passes, the touchdowns, the fumbles, all the antics that happen when somebody makes an error. All this stuff tells the whole story of our sports ball game, gets us to that final score. And that's what we really want to know, right? When you go to watch a game, you don't go to sit there and, oh, somebody scored, okay, look back down at your phone. Oh, someone scored again, look back down at your phone. You're interested in watching all this unfold. You get great value out of it unfolding. Now, it is similar with our business workflows. So an event, a business event, a domain event, whatever we would call it, represents the fact that something specific and relevant happened within a particular business context, a particular workflow. And we believe that those events have great value to your enterprise. We believe there is a lot that can come out of storing those events, using those events to gain the full potential of your business workflows. Mike. Stop breaking stuff.
I know.
You're going to get in trouble.
I almost hung myself on the wire.
You're just kicked out.
Right, but this is a conference about GraphQL, right? So you're all sitting there, okay, right, I don't want to get mixed up with these weird event people. You know how they are, always arguing about routing and naming and channels and all these kind of stuff, right? But as it turns out, GraphQL has like a pretty resonant concept here that's like right in front of us when it comes to like the idea of a domain event, right? I mean, this example will be, I'm sure, familiar to many. I took it directly from Apollo's introductory documentation, right? But in GraphQL, whenever we change state, we use a mutation, right? A mutation is something that exists in your schema specifically for this purpose, to like cause a change in state, right? Almost universally, right? It's like a named function with some parameters and values and a return value, right? And so it's right there, right? Like all the context that you need for a domain event is the why. What's this thing called? Why is this happening, right? And what's happening, like the how of it, right? These are the values, the names of the parameters. And then you might also include like the return type as part of the context of like, not only what happened, but was it successful in the reasoning around it, right? So basically it's just a first order citizen in the world of GraphQL that's like ready made for capturing change, right? And we can capture them very easily as events. And so mutations, dear listener, they're the domain events of the GraphQL world, right? And it's like any occurrence of significance to your business is going to have an associated mutation, right? And any mutation in your schema is almost certainly an occurrence of significance in your business, right? It's right there. Like you've already done the domain modeling, like you've captured everything that sort of can happen as mutations, and it's just waiting to be taken advantage of in order to like capture this in a meaningful, useful way, right? But events are like Pokemon, right? You got to catch them all, right? Because if you miss one, you get the score wrong at the end of the game. You have to know everything that happened in order to correctly come to current state, right? Which of course is still important. We're not trying to say that state is like can be ignored, right? So how do we go about capturing all of the mutations that occur in a GraphQL or an Apollo-based system, right? There's a typical sort of simplified architecture for an Apollo-based system. You've got some clients on one side, you got Apollo in the middle doing what it does, which I won't explain. I'm just going to assume everyone has like a basic idea, right? And then a bunch of microservices on the other side, right? Those microservices are servicing different parts of the subgraph and handling mutations of their own right? So you could try to capture everything on the right-hand side of this thing, right? But then you would have to instrument every one of your microservices, and some of the mutations might actually be spanning microservices, right? And even if you do it, then you still have to get everything you recorded out of them into a singular store again, and you've just created like a bunch of like mess and problems, right? You could try to do it on the left side, but this is like a slightly like unreliable part because you're counting on your clients to record information about activity, right? It doesn't work great, right? Luckily, with Apollo GraphQL, you can have it your way. Does anybody know this familiar logo? No, this is ChatGPT's idea of combining Apollo with Burger King, which may seem familiar, but you can have it your way. Like Apollo GraphQL provides us with some excellent options for customization, like directly in the router, right? And the router is the perfect access point for getting at all the mutations that are happening in the system, right? Because everything's going through it and everything's coming back, right? It's an orchestrated API. It's an access point where you can get your hands on everything. And we have a couple different ways that we can instrument this thing, right? Rye scripts, and you can do code processors. In this case, we decided to do a native Rust plugin. Because of what we're doing, capturing all the mutations that are happening, we need this thing to be fast. It's got to be lightweight. And we just wanted to have full control over what's going on and not have to face any constraints, right? So we settled on item number 3, but there are a couple like options that someone might employ, right? And then, of course, when you have a radical software idea that you want to share, the first thing you do is start a GitHub repository. So there you go. This thing's available as open source. It is, I confess, a little alpha, all right? But it does implement and correctly demonstrate what we're trying to do here, in that it captures every mutation that's passing through the router and stores it into current DB as an event, right? There'll be a QR code in a bit, so you don't have to write that URL down or anything like that. So it's coming around that. Just to make it clear how this works, like you start with the standard architecture, right? And just by adding the plugin and an instance of current, now all of a sudden you're capturing all the change that's going through your system that you might not have been capturing somewhere else without having to change your application code. And it's already all in one place. You don't have to re-aggregate it, right? So it minimizes the amount of work that you have to do. So that's like the what did we do, right? We created this thing. A lot of you may be thinking why, especially you, sir, have the most quizzical look on your face I've ever seen. Okay, so some of you may be relieved to learn that I'm going to take a break from talking and Tony is going to go into a little bit of the why.
Right on, thanks.
Mm-hmm.
Okay. Let's get a little bit of real world stuff here. I love real world stuff. So let's take an example of applying for a loan. So everybody in this room has almost definitely done some kind of bank loan application, credit card, mortgage, car loan. I don't know, maybe some people have yacht money. I don't have yacht money, but I imagine there's loan involved there as well. Now, if your bank is like mine, it's about 7 bazillion steps to get from application through firstborn child and signing them over and all the rest to funding, right, to approval. But for the purposes of our demo here, I'm going to distill it down to 4 major steps. So we're assuming that we've got a loan application system where we have a human being sitting at a laptop or a mobile phone, putting in all the information that you would need to give to your bank in order to get approved. So your basic contact details, employment, dependents, all that kind of jazz. And you'll click that big red button that says go, and your loan will be requested. So in our world, that would translate into like a loan requested event, right? I've given all of my information, and I have started that loan request process. So from there, the second process, this is more of a headless web service that would be listening for loan requested events, would then pick up and say, hey, I have got a new loan request. I need to go and check Tony's credit. Bad idea. Alarm bells go off, red sirens, automatic deny. Just kidding. Or maybe it is, I don't know, I don't talk to my bank that much. But the fact is that we have this process that's going to go off and be listening for loan requested events. It's going to then go off and do a credit check, simulate a credit check in our example here. We'll then store that credit check as, can anyone guess? Another event, credit checked event, right? We're changing the state of our loan application to say, I'm adding this credit check. That to us is a credit checked event. So we'll store that as well. Now the third step in this process will be yet another headless web service that is going to listen for new credit checked events, listen for new credit checked mutations. If that has changed, that state has changed, and we now have a credit check, we can maybe make an automated decision about whether to approve or deny this loan. Is my credit score high enough that I can approve it? Is it low enough that I need to deny it? Or does it fall into that kind of meaty middle where we should get a human being involved, let them evaluate the application on its merits, determine if the bank wants to take on that amount of risk? And that will be our fourth component. The fourth component will be underwriting. So the underwriting component is going to be waiting for loan approval needed events. It's going to be waiting for an application to get into a state where a human being that needs to get involved. In our world, that is loan approval needed event is generated by my loan decider component here. Now when we get into the underwriting app is then going to present all of this information about my loan request off to an LLM and ask, summarize this loan for me. Tell me areas that my underwriter should dig deeper when deciding to approve or deny this loan. Okay, so we'll talk about how we can feed these events into LLMs as well. And then we'll kind of end our process here by either manually approving or manually denying this loan. Okay, so again, another state change, another event. Now, when we make all these state changes, we're going to store all of these events, all of these mutations as events inside Kurrent DB. So Kurrent DB is an event-native data platform that stores and streams events in their original format. We don't force a data model on your events. We don't force you to change schema to fit a particular domain model. What we do is we take your events, we append them, they have an event type, they go into a fine-grained stream, they have a time, and they have data and metadata payloads that describe the mutation that took place. Now, why is all this important? Well, you might be saying, well, Tony, I have Kafka. I'll just put all this stuff in Kafka. Well, Kafka is really great at moving events in large volume from A to B. What it's not great at doing is storing those events in a way that you can quickly access just a subset of them. So when I say we're appending these events into fine-grained streams, what I mean is you are putting the event into our immutable append-only log. That event is durable forever, guaranteed to be in order, but it is also accessible using the name of a fine-grained stream. You can think of that name kind of like an entity name. So it could be something like loan request -123 that would identify just my loan request from Mike's loan request, from your all loan request. And by using that stream name, I can get just that subset of events that make up that particular entity very, very quickly out of the database. Now, Kurrent's got a ton of benefits for both the business as well as the technology teams in your organization. Keeping your data globally ordered and immutable means that you are fully auditable. CISO loves it. They love to be able to call you up and say, hey, did Tony really order 100 shares of Acme Co? Oh, let me check. Yep, Tony ordered 100 shares. Perfect. I can't go back and change time, which means I have this continuous record of what happened. I can't do an update command. I can't delete an event out of the middle of a stream and just pretend something didn't happen. These events happen. You can't go back and erase history. But you also get these highly granular pieces of data. An event contains all of the data elements that changed, and only the data elements that changed. I don't have a bunch of empty values unless they're valid. I don't have a bunch of nulls unless they're valid. I don't have CNAME underscore FNAME as the field name. I have customer first name, right? Rich context, rich detail, lots and lots of information there in natural language. What do LLMs love? Natural language. Match made in heaven? I think so. Peanut butter and chocolate? Yeah. Right on.
Making me hungry.
Yeah, exactly. Now, put your hand up if you've ever implemented a business workflow that has never changed. Right on. Businesses love to change their workflows. They love to request changes to their application. And of course, with good reason, right? The business changes, or you learn something new, or you try something that doesn't work, and you adjust, you change. Well, with Kurrent, you're storing all the events. You can change the workflow on top. We don't care what the workflow looks like now. We have all that data there that you can then use to walk backwards and forwards through your workflow, that you can replay at any point in time, to any point in time. If there's a bug in your code and you're trying to track it down, it's super powerful to be able to walk backwards through your changes, through your mutations, and see what changed, where, and when, allowing you to go back into your code and quickly fix it. Put your hand up if you know what the next big technology is to come down the pipe. Put your hand up if you know the next big feature that your business is going to ask you to implement in your software. Okay, that last one you might know. But chances are, none of us know really what's coming next. At one point it was BI, now it's AI, EIEIO, I don't know what the next thing is, right? But I do know if I have all the events that my customer workflows have ever generated, I can populate that new technology. I can populate that new feature with all of my historical data. And I can start using it now, not in 6 or 9 months when I've built up enough data with it in order to get value from it. I can use it now. So tons and tons and tons of value, both to the business and to the technology teams of storing all of these events. So what does this look like? So we have these processes that are off, some of them headless, some of them interacting with customers, all of them generating events of some kind. We take those events as they come, left, right, and center as your business is operating, right? We put them all in this globally ordered, immutable log of events. Everything is durable. And we put fine-grained streams on top of them to get only the events related to one particular loan application. Globally ordered, of huge value, right? The credit check can't happen before the loan has been requested. When those events are made durable, they're put in an order, and I can recall them in that order to walk from the start to the end, from the end to the start, start in the middle and walk forwards or backwards, start at revision number 1000 and walk to 1005. I have all this data that I can march through, and it's all ordered. And this is what we call a fine-grained stream. Here's an example. Now, each event is really just a big text blob. Now, you could put protobuf or Avro encoded data in there. You could encrypt it if you want. But at its heart, most of our customers are simply taking a JSON string, a big JSON payload, and putting it into the event data payload. So what this looks like here is as I mentioned, very descriptive field names, very descriptive data, right? Full of information that you can feed off to LLMs, that you can transform into a different format if you want for consumption by another tool. Just to show you what that actually looks like, because I don't need to put an eye chart up there. Sorry about that. Should have clicked forward. But this is the anatomy of an event. It's data payload. There's also a metadata payload. Now, the metadata payload allows us to correlate events together with a correlation ID. So find a string of related events, build that digital thread, right? Causation ID. This event was caused by this other event. Or another way to look at it is this event caused this collection of other events. So we can embed this straight into our metadata, along with things like OTEL, or some kind of traceability, auditability, transaction IDs, whatever you like. It's just descriptive data, and you can use that to your advantage when pulling this data out downstream. So what can I do with my events? Now I have all this data. So what, Tony? I've got all these events. So what? Hear that all the time. Well, now I can build whatever read models I want to serve whatever purpose my customer or my business needs this data for. Rich analytics and reporting. You don't have to go back to the warehouse person, to go back to the ETL person, to go back to the ODS person.
Sorry, Tony.
You're killing me here.
I couldn't figure out if I should cover the mic or my nose.
Bless you.
I had a moment
You have
of...
2 hands.
I panicked, I confess. Please carry on.
You don't have to go back to the ETL person, to the warehouse person, to the ODS person to say, hey, I need this field, I need it brought forward, I need it transformed in this way, it should be called this thing. No, I already have all the data in one place. Kurrent is often used as an operational data store, so sitting directly under the applications and processes that are supporting your business. So I can take data from that and apply what we call a projection. A projection is just a transformation of an event from one form to another. And then I can use it to populate what we call a read model. And that's just another way of consuming that data. So I can use a projection to transform the events into a new read model in a relational format, a state-based format, to feed to my BI tools. Tableau speaks SQL. Build a read model for Tableau that includes all the data Tableau needs, or in my case here, superset, because I'm cheap and don't want to pay for Tableau. And I get pretty graphs and charts that tell my business how my loan application system is operating, right? I get lots of information into those charts because I have all the data, and I only need to do that transformation one time into the format needed for that report. AI. We're all here to talk about AI. So I told you that part of our loan application system here, when we get to the underwriting stage, is to ask an LLM to summarize that loan application and give the underwriter areas to look deeper when deciding whether to approve or deny that application. LLMs love natural language. They're written to consume and process natural language, and events lend themselves very well to being processed by AI. So much so, in fact, that my example here simply takes an entire stream of events that makes up a loan application and credit check, puts that into a system context, tells the LLM something about my fake made-up numbers, like what's a good credit score, what's a bad credit score in my range of 1 to 10, because 400 to 800 for a credit score makes no sense to me. I don't know.
I think
Anyway.
that might be the SATs.
There's something like that.
Yeah.
I don't know, we pick all these weird number ranges, right? But if you can tell the LLM what some of those things mean, give it the raw, unprocessed, untransformed events that are relevant for that particular use case, ask it a question. I got back a JSON payload, which is, by the way, anyone guess, what is this return? Another event. Pay that man right there. Put him on staff. So that is another event that we store. We store the results of asking the LLM to summarize that and give me more areas to dig, right? At the same time that we're enabling our staff to make faster decisions, smarter decisions about our customers. I can do the same thing by building a chatbot. Imagine if your chatbot knows everything about my loan request, everything about my loan application. My chatbot knows the entire history of that process. I can ask it questions and it can pull the answers straight out of the loan application, saving your L1 agents time, right? Taking them and putting them on deeper, more important things for them to answer than just the stupid questions that I asked my chatbot here. We also are getting into the business of MCP servers, right? Apollo has their MCP server. I will never get that acronym right. I don't know why. Apollo has their own MCP server that is able to use the data from Kurrent, right? That data backs your services, and it can come straight from Kurrent. We have our own as well that's able to help you get started with our platform and building your projections, testing your projections, interrogating and understanding the data in your streams. What do I have available to work with? So you can use Kurrent's MCP server, and we're looking to add lots more capability to that over time as well. Things like connectors, things like working with the internals of the server, monitoring the server. All these kinds of things are great candidates for an MCP server. So this is running in Claude on our desktop. You can embed that straight into VS Code as well. So Kurrent is applicable, as you can imagine, to a lot of different use cases across a lot of different industries. In fact, I think we're working with a lot of you today, maybe with or without your Apollo team, your GraphQL teams. Anywhere you've got application development or application modernization, and that application is speaking events or wants to be more real time, right? We've all come to expect our applications now are real time. I do a thing, I should be able to see the thing and interact with the thing and have the thing. That's how life goes today. Well, that lends itself really well to events, and events are Kurrent. Real-time monitoring. Again, data flowing, right? Things happening. A thing happens, I want to monitor it, I want to process it, react to it. Data pipes. AI and agentic workflows, all very data-intensive, data-hungry things that we want to be able to action real time. That data lives inside Kurrent, and our customers are taking advantage of that data. So Mike, what's the final verdict here?
Final verdict, don't leave your change behind. Get that money out of the couch cushions and pick it up. Get all the value that's available in your data stream. And your investment in Apollo can make it easy to capture your change in Kurrent, right? So because you've put all of this effort into orchestrating all of your APIs through a single access point, that then allows you to do this sort of value adds, like capturing all the change, all the mutations in one place, storing it in another location that's explicitly built for making use of this kind of data and enables all kinds of new opportunities for you.
Right on. Couldn't have said it better myself. So what are customers doing today with Kurrent? Well, does anybody actually in this room see their logo up there? Anybody? I can't see this. Blade is like an aircraft landing. No, it's hard to tell. Okay, maybe not. So organizations these days are getting a lot closer to their customers, making a lot better decisions about and for their customers, saving lots of time and money in their building up their platforms, getting their features to market. And with our partnership with Zolvio, Mike's going to tell us a little bit about how we can work together.
Why not? So I think we currently work together on maybe a few of these logos, but it just came out a few days ago that we're now the official first professional services partner for Kurrent, which we're very excited about, of course. Close relationship. getting closer. As it turns out, we were also the very first pro services partner for Apollo a zillion years ago, which is a relationship that we think has matured well. You may have seen me speak at this thing last year. Was anybody here last year? Thanks for coming back for more, by the way. Like, that's very nice. I appreciate it, guys. And we've been at like summits and sort of like part of this community for a long time, so we're kind of proud to be here. And to be working together on all these great like customer outcomes, right? So this is like because this is a conference, we've got a couple kinds of free things, right? Both kinds of free things. Free is in software. That's the link to the GitHub repo where we've got the plugin, which you're welcome to get and experiment with and try out. And we'd love to hear about what you want to do with it or how we can help evolve it together. And then there's also free as in beer. You can get $200 in free Kurrent cloud credits. So you can get that thing out and kick the tires and open and close the doors and change the stations on the radio or reprogram the interface. Whatever you do with cars these days. I don't know. They've changed a lot during my lifetime, you know. We both sponsors. We both got booths here. We would love to see everybody. Please come by. There's also some nice freebies there, notebooks, T-shirts, stickers, all that kind of good stuff. Before we take some questions, I just want to say thanks to Apollo for throwing the event and hosting us. It's been fantastic. And of course, thank you, all of you, for coming and for your attention. And the most valuable thing of all, of course, your time. Any questions?
Let's get some applause first. That was amazing. All right, who wants to go first? Is it a question about sort of the technical details of it or the concept? What do you got for us, Nick?
Ladies and gentlemen, Nick Beach.
And it is point
No.
blank. Okay, so Tony, you had showed on the screen, especially in retail, which is the domain that I'm from, that you can basically do your personalization stuff off that customer journey. However, if the customer journey that we concern ourselves with is not just mutations, if we want to know, you know, what did the customer view, how long did they view it, and things of that nature. I mean, I understand we could turn around and do basically an event stream from the browser, you know, using a mutation, but is there a way, and maybe this is more for Mike, that it can be done through the connector where even queries can be recorded as events?
You certainly could. So the techniques that we've used for plugging into the Apollo router don't preclude you from recording queries. Our basic supposition is that the sort of change that we're looking to capture, like the essential change, right, it all comes as mutations. And that when I first threw this idea out, Dan was like, that would be an intolerably large volume of stuff to write, like because the ratio between like queries and mutations in I think most like supergraph implementations is very high. Right? So you could approach it that way. It's possible. In this first pass, I think the experiment is mostly around like the kind of change that we expect to see within a mutation. Does that vibe with your take on it?
What he said.
That I said, okay. Yeah.
Yeah. Short
All right.
answer is yeah, definitely possible.
Okay, we'll come. I'll be right back.
This is going to be a good one, I can tell already. Look at this. This is going to be a good question.
No pressure. I took note of your application for Kurrent in feeding events to an AI agent essentially as context to support that agent's working on its goal. What about using Kurrent to capture the events generated by the agent itself? So for example, inspecting, you know, what prompt did it use, what tool call did it make? Is that as well possible?
Yeah, absolutely. I don't think we have a customer doing that today, but I certainly see value in that, right? There's just an explosion of AI tools right now. So if you have a way that you can capture those events.
As it turns out, we're doing this with a customer right now.
Oh, perfect.
Actually, we're specifically using Kurrent for capturing this kind of information to feed the process of optimization that has become kind of like the norm within LLM-fired applications, right? You know, like that usage data is just like absolute gold in like not only getting right, but continuing to be right in an application who is like fuzzy by definition.
All right, there's so many questions that could ask there around like experimentation and, you know, so are you piping that to like Brain Trust or Arise, or do you have your own platform for that observability?
A little from column A, a little from column B. Do you want to kiosk this one?
Yes.
Yeah, that's good. This deserves like a deeper
Thank you.
conversation. Yeah, the guy, the dev that's who's developing this, whose name is Dev, as it turns out. It's strange because he's knocking around in here somewhere too, so he'll have a lot to say about this. I would include him in the conversation. Yeah. knew that was going to be a good question. I could feel it.
Yes, indeed. And another one.
So if I understand this correctly, we are saying whatever the application logs is what goes as an event. Have you considered PII data? How that
Excellent
gets...
question, right? So
my name is Lakshmi Thadi. I'm from Ford Credit.
Ford Credit. You guys care about privacy? You
Yes,
definitely
of
care about
course.
privacy.
That was rude.
They care about privacy.
Yeah, that was rude.
No, I was just trying to make the point is like in financial world, privacy uber alles, right? It's the most important thing, right? So we have built this thing so that it just takes everything that's a mutation and writes it, all right? Our next item on the list is make a positive list of things to write, all right? So that you are only feeding into the system explicitly what you want to store this way. Because it does have the potential for just being like a giant security hole in the middle of your router, right? Acknowledge that that's the case, right? But I do say a very easy way of solving that. There's also the option of anonymization or the other kinds of, there's other kinds of techniques that people use specifically to keep that data still being useful to LLMs without just like eliding things that might, at least they're like consistent representation, although it may be not retroactively computable, right, would be useful.
Yeah, we have a number of techniques that we use with our customers who are not using GraphQL. I don't know why anybody would not use GraphQL, but there's a number of techniques around that. So encrypting the PII as it is put into the data payload. You could encrypt the entire event itself. You could use our encryption at rest feature. You could also store the PII in its own stream, separate from the main entity information. You can store it off in some other data store. All of these allow you to kind of delete just the PII or encrypt and crypto shred the key for the PII, for example. So lots of different techniques we can use there. Some of those, as Mike said, you would need to build into the router customization, and we're looking at expanding that. Some of them you could do at the application level as well. So before it makes it to the router.
I was hoping you'd say crypto shred. That's like my favorite word.
I tried to throw it in there
So
just
cool.
for you,
Crypto shred.
So follow on to the question. You talked about chatbot. So is there, how would I say, customization where the chatbot cannot have access to certain data and have access to, like, policies or things like that?
Yeah, absolutely. Actually, I don't know if you can read it on here. How far back do I need to go?
I'll move the screen closer to you.
So part of that is just not giving that particular piece of data to the chatbot.
Yes.
Part of that could also be instructing the chatbot through context. You cannot answer or provide this information back to the customer. So if you look at the answer to the first question, I don't know if that's readable. I can't read it, but that's my problem. I don't know about you folks.
Hello.
Yeah,
Your national ID number for privacy and security reasons. However, I can confirm that
Nice.
you are.
Okay.
Thanks, Dan. So you can absolutely accomplish these things with AI, and even excluding the data from being sent to AI. In fact, if you encrypt it as part of the payload of the event, it won't even be visible because the AI won't have the key, right? So it'll just appear as this jumble to the AI.
Got it. Thank you.
3 for 3 on good questions here.
Right on.
Rolling.
I only charge 1 beer per question.
Do
so-
we have, by the way, free beer is available tonight at Apollo Fest at 6 p.m.
Right
Come
on.
on by.
Apollo.
So-
I'll be crypto shredding on my skateboard.
how about this side of the room? Who has a question? Anyone who's using events, who does it through the, deeper in the stack?
If nobody has a question, I have a question.
I have a question.
Good, Dan.
We're going to
Well,
run the record.
You go then.
Well, the question is, okay, great.
Oh, this looks like a tough one.
Yeah.
Be ready.
Okay.
Be ready for this.
Hello, my name is Artem. I'm from Bloomberg. It's not a technical question, but I saw on one of the chart you are using superset.
Yep.
But not by. But my question is, why you are not on the list of supported databases?
Great question. We're still fairly new at it. Now, our database does not currently speak SQL. So it's not a direct plug into Superset. So right now, our product is taking the events and translating them using a projection into a Postgres read model. So that is actually the path that most of our customers follow. So for the demo, that's the path that I followed. But we're looking to change that. So in a release coming, 26.0 release, which should be out sometime in November, we hope. Don't count on that. That's a safe harbor thing. Don't tell the lawyers I said that. We are anticipating our first cut of our SQL interface to be released. And the idea will be to do exactly that and have superset or Tableau or insert SQL-based tool here be able to go directly to our database, send analytics type queries, and get the results straight out of the database.
Excellent. Oh, right over here.
Also not a technical question.
Sure.
Can you explain a little bit about your pricing model on the 7 cents per hour thing? On the
I
instance?
mostly come to these things for free.
Yeah.
Oh, great. Thank you.
No, just kidding.
So from a pricing perspective, we have an open source version. We also have a number of really great enterprise-grade features, things like OAuth and LDAP integration for security, stream policies, lots of encryption capabilities, archiving, all kinds of great stuff. So we typically license by CPU right now. And there's a couple of different editions of the product, and you add support on top of that because you don't ever want to take something unsupported into production. So yeah, does that answer your question?
We have at least one amazing partner with very acceptable pricing.
Yeah, they're pretty spectacular.
Come to the kiosk for more details. I have a question.
Of course.
Happy path, we log things. What about the unhappy path with events? What's best practice here? Are we supposed to wait till the sort of commit occurs and log that? Do we just log the attempt? Do we do both? Do we log errors? What's the best practice on things like this?
We log, oh, you go.
So you mean the happy path as in you
Well,
failed,
mutations fail.
or the mutations fail, yes.
Yeah.
I mean, the failure, so there's a couple ways that I would think about that. First and foremost, do you care? If you care, those failures are in fact events themselves. And we should try and log those as well. I'm sure you've dealt with this in a number of implementations.
No, and the clear delineation of like what is a domain event in our world is like, is this of significance to the model that you are working within, right?
Yeah.
And in most cases, we're recording something as a historical occurrence, right? It's like something happened, right?
Yeah.
And so we would want to add to this, and in a production footing, we're only recording events for things that actually occurred, like unless capturing of error is part of the domain, in which case we would do that.
Yeah.
All right, so.
Absolutely.
True.
Yeah. And things like, so correlation and causation ID allow you to kind of trace that thread, right? Now there's a number of industries where a failure is in fact a thing that happened that is valuable, like a payment failed, or a checkout failed, right? I failed to authorize the credit card, and so I want a team to go and investigate that, or get back involved with the customer and say, hey, what happened there? Stuff like that. So there are certainly those kinds of failures above and beyond just the action didn't take, right?
Anyone else?
One quick question for me. Have we puzzled you to death, or you just have a naturally quizzical look? You, sir. I kid, as a speaker, because you're sitting there and you're just like.
I can't believe you can see the faces. This light is blinding me. Okay, well, folks, thanks a lot for coming. We have a kiosk upstairs. Please drop by, get a free shirt, have some conversations. We'd love to hear your story and what you are doing and how we can help Xolvio with implementation, Kurrent with the data storage. Come hit us up for some beer tonight. We'll be there to buy you a free beer from the free beer thing. I guess we're not really buying. That joke didn't work well. Anyway, love to see you tonight. We'll all be there. And thanks again.